welcome, Avik.
Thank you. Does that work? Cool. Um, Thanks for coming. Hope you're all enjoying JuliaCon. This talk is based on work that was done by my colleague George Day at Julia Hub. Unfortunately, he couldn't be here, so I have been volunteered to do this and bring this to you. So what we're going to talk about is using Julia in secure code environments. As an example, we did work for the US Air Force, where a lot of the development can and does happen on unclassified or open environments. Again, there are obviously different definitions of open, but certainly, things where some version of internet access is possible in development. But a lot of the deployment happens on classified or secure networks where internet access is completely not available, primarily because the data in those environments are very sensitive, right? So even though the code that is being developed may not be that sensitive, the data that it operates on is very, very sensitive. So for example, the work that we did for the Air Force was about developing some data visualization, some data analysis software for some kind of secure data that they had. The analysis itself was done on an open environment, but the data itself came from devices that were very secret. So the question then is, how do you get your Julia code, including all your dependencies, the Julia packages, the DLLs, the JLLs, how do you get them into the secure environment that you can then run your code on the data that is in that secure environment? So this can be, if you imagine adding a package, which is, if you're doing a data visualization project, you will have some kind of plotting library, Marquee or plots. So the first thing you would do when you want to run this code is add the plots package. And if you do that without internet, everything works. If you do that with internet, everything works. If you do that without, then the first thing that Julia tries to do is update the registry. That'll immediately fail. Julia sort of tries to continue even if the registry is not available. It tries to determine the highest compatible version, which it will try if it has a local registry. If not, it'll fail. If it has a local registry, it'll try and get the package version from the package server or from GitHub, and obviously that'll fail. So you will not be able to get the code that you want for the dependencies that you have without internet access, right? That is how Julia's package basically works. It assumes you are in a connected network. So before talking about solutions, let's talk a little bit about the sort of scenarios that are possible. The easiest one that we will talk about most is you can move text files and artifacts into the secure code environment through some form of constrained file copy, essentially. There are other environments where you can only move text files and no binaries, and we'll talk a little bit about that. Where sometimes binaries can be installed in the environment already. Sometimes binaries are not installed and you can't copy them. And that becomes very difficult. The fourth scenario is, of course, that you want to do all of that, but for more than one application, more than one user. And how do you do that? How do you do that multiple times? So the solution that I want to talk to you about today mostly is a package called DepotDelivery, which was developed by Josh for this project. And what DepotDelivery does is essentially very simple. It starts with an empty depot. For those of you who don't know, a depot is where a Julia installation keeps all the dependencies that it uses, right? So all the packages, some settings, all the binaries that it downloads, everything is kept in a depot, which typically is .julia in your home directory. But of course, you can set it to anything else, right? So what DepotDelivery does is starts with an empty depot. It does pkg activate, which then uses the package toml that exists in a certain directory, and then instantiate it, which basically installs all the dependencies that you have. And finally, what you need to do after that is to move .julia, move the contents of .julia or the depot into this environment, right? As I said, through some version of constrained file copy. And that looks easy to do, right? All these 3 steps you can do manually, and that's certainly possible. You could do that today. But it's cumbersome, right? You have to keep deleting your .julia directory or a depot every time. A particular problem is that child Julia processes don't use a depot that you have configured for the parent. It uses an environment variable directly, so you have to remember to set it, and sometimes we forget, and that fails. Second or third, your build environment has to be identical to your deploy environment, right? If you are building on Windows, deploying on Linux, this process does not work, right? And finally, if your project is not, the project that you're developing, the stuff that you are writing yourself, if it's not in your depot, if it's not in .julia dev, you'll probably have to move it from somewhere else, which is always annoying, right? So depot delivery basically automates all of this, does that consistently every time that you run it, because obviously with a manual process, things can change. And so what depot delivery does is that you just use a build function with a path where it creates this bundle. You can give it a platform. That platform can be the default platform that you're on, or it can be a completely different platform. So on Windows, you can do Mac. On Mac, you can do Windows. And that's it. That this one function will create a bundle in the path and return the path to that bundle to you, right? You can, as I said, build for a specific platform. You can use any of the platforms that Julia supports by default. Once the depot is created, once that bundle is created, you essentially move that bundle to your secure code environment. And in your Julia session, you just include this depot startup file, and that will set everything up for you. After this, you can code on the REPL by normally you can run your own script, and all of that you can do exactly how you would do once you have done this depot startup, right? So let's go back to the scenarios we talked about. If you can move text files and artifacts, then this method that I described works very well. If you can only move text files and the binaries are installed in the secure code environment, you can move the bundle without the artifacts, without the .sos or .dlls, and you can use something called overrides, which Julia supports, to point to DLLs or .sos that are already installed, right? That works. If those DLLs are not installed and you can only move text files, you basically have to rewrite any binary dependency in pure Julia. So one example is, there's a package called xml.jl, which Josh wrote, because the other XML packages essentially use C libraries, right? And the last one is, if you have to do this for multiple users, this is always annoying. One potential solution is, the Julia platform, which, this not being a sponsor talk, I will not talk about too much, but you can go and talk to the people at our booth. And that's basically what I wanted to talk to you about today. Thank you. Any questions? I think we have time for 1 or 2, maybe.
Yes. Questions? Nope. Anyone?
Yeah. Can you use the mic, please?
Oh.
Thank you. No, I can't hear you.
1, 2? OK.
Perfect.
Yeah, so thank you very much. I am in that kind of environment.
Yeah.
So I'm going to bring the lessons learned back home.
Sure. Thank you.
Thank you.
And I'm around for the rest of the day and tomorrow, so come talk to me if you need. Thank you.